let's see, let's do it this way. Okay. What's the lateral area?
So to find that, I don't remember exactly the formula.
Well, the surface area is the sum of all of the faces.
All right.
The lateral area excludes the base. So the lateral area would just be this side, this side, this side, and that back side. So let's talk about the lateral surface area, or the lateral area first.
All right.
What do we got here?
Looks like 5 centimeters.
Times what?
12 centimeters.
No. What are the dimensions of this right side panel here, where I'm pointing my cursor?
It'd be 5 times 5 times.
Where are you getting the second?
Oh, 5 times 2.45.
Okay. 2.54.
All right.
And then how many of those faces are there?
2.
Okay, so we're going to multiply that by 2.
Yep.
Plus this front face and the back face.
So 12 squared.
Not squared.
12 times 2.54 times 2.
Okay. So that gives us the lateral surface area. What's the area of the base?
The area of the base, that would just be 12 times 12 to get 144, right?
No. What's the area of that base? Look at it. What are its dimensions?
Oh, okay. 12 times 5. I'm sorry.
Okay.
So 60.
Okay. So that's 12 times 5. And so the surface area is the lateral area plus the area of the base.
Okay.
So I'll let you do the arithmetic. The arithmetic is not of major concern to me, but the setup is. The setup is what lets me know that you know what you're doing.
Two. And then, can you go back to that? Yeah, I see the area of the base. 12 times 5. So it comes to 120.9.
It's almost better if you don't figure it out. You understand why?
No.
Because I'm not testing you. I'm not trying to teach you arithmetic. I'm trying to teach you the geometry, and all of the problem is setting it up. In other words, if you know how to set it up, I know you know how to take your calculator and multiply these out. That really doesn't do anything for you or me. And in fact, I personally believe it kind of takes away because it gets you focused on something you don't really want to be focused on. You want to be focused on how we set these up.
Okay.
For you and I, it really is almost a waste of our time to spend on doing the arithmetic. Yeah. I mean, you can do that on your own time. You don't really need to pay me to have you get those numbers. But I really truly believe that you will learn this material better if you just get the problems to set up and solve them later, because that gets you to focus on how do you set all of these up.
All right.
So let's talk about the surface area and cylinder of this and leave everything in terms of pi. In other words, don't convert it.
Right.
So,
So for this one, you do pi r squared times the height.
that would be the volume.
Oh.
In other words, the volume, because it's like a prism, it has two parallel and opposite bases, and it's
Right.
consistent between them, then yes, the volume would be the area of one base times the height.
Okay.
Surface area is different.
Right.
In this case, surface area is what? It's a combination of two things.
The lateral area times, I'm not sure.
Plus
Remember.
what? The lateral area is the side area. What else is there?
The base?
Well, there's two of them. There's a bottom base and a top base. So it's two areas of the base.
All right.
Okay? Let's do the easy one. The area of the base. What's the area of one base?
That's pi r squared. So we
Okay.
got 64 pi.
Okay, let's just leave it like that. Now let's talk about lateral surface area. What's
All
the
right.
lateral surface area? What
Um,
analogy have I taught you to use here?
4, 5
No, a
times.
soup can.
Right.
The label of a soup can. If this was a soup can and it had a label around it that just barely fit, we would want, and then we unfolded that label, we would want the area of that label, correct?
Right.
That label would unfold as a rectangle. What's
Right.
the height
And
of,
then
what's the height of my rectangle?
the height is 11.
Okay, what's the length? What's the width of it from here to here?
Is that 16 then?
No. What is it? I want you to think about it for a second. Remember, the label just barely fits. It goes from this point all the way around and comes back so that it just barely fits. If I held up a dollar bill and made it a circle, what would its length be?
Would it be 64?
Nope. Actually, I'd prefer you give me the answer rather than a number. I would prefer you give me the answer of the concept, because you'll remember the concept. It's the circumference of that circle.
Oh, okay. 2 pi r.
Right. So what is it?
16 pi.
Okay. So that's the dimensions of the soup label, and that's the same as the lateral area. So that's 11 times 16 pi. We'll just write it like that. 11 times 16 pi plus 2 times the area of one base. That's all we need to go. The concept here is the length of this rectangle is the circumference of the circle.
All right. Circumference of a circle. Alrighty.
The circumference of that circle. Okay, here we have the radius of the base of a cylinder is 28. So this is the same problem as before, only different numbers. Here's our soup can. Radius is 28, height is 48. So the surface area is what?
The lateral length plus the 2 times area of the base.
Okay, well, what's the area of the bases?
Area of the bases is 28 squared.
Okay, so we
pi.
have, yep, so we have 2 times 28 squared pi, and that's
Right.
it.
And then,
What's the lateral area?
so the height is 48, and then 2 times 28 would be 56. And then you got it.
No, we need a pi
50, yeah, sorry.
because the circumference is 2 pi r.
Right.
Always remember that when you're dealing with circular areas, you're going to have a pi in your answer. When you're dealing with objects like this,
Anything that's not a circle won't have pi in it.
exactly, that's not going to have a pi in it because that's a pyramid. There's no circles anywhere in that. But if I put a cone, that's going to have a pi in both the surface area, the volume, the area of the base, all of it. So when you see circles, look for pi's in your answer. If you're missing a pi in your answer, you've probably made a mistake.
Okay.
Okay? All right, and let's leave it at that. You kind of see the advantage of leaving it? Because we don't get hung up on the arithmetic, and we're able to concentrate on the concept. And I think that's actually pretty beneficial to you because I think it's easy to get distracted by the arithmetic. Okay, so we want the lateral area of the pyramid shown to the nearest whole number. And that's because there's no pi involved in this thing. Right. So the lateral area of the pyramid.
To get that, doesn't that form a right triangle?
Yeah, this is going to be a little harder than it looks. Let's start. The total surface area would be the lateral area plus one base, the area of the base. And they're only asking for the lateral area. Do you remember the formula for lateral area of a pyramid?
Yeah, it's half the perimeter times the lambda.
Exactly. And lambda is measured not with this red line, but with an altitude. If I look at this right triangle here, I didn't mean the right triangle, I meant the triangle on the right.
Yeah.
And you were to draw an altitude right down the middle of that so that it came to right here.
Yeah.
That's lambda. It's not this vertex length. It's not that length there. It's down the middle of one of those sides. So they've made it more difficult for us because we have to calculate that triangle. So let's make a new triangle where that side would go to that point, and then we would connect that to that middle point so that now we have a triangle that we can solve, and we can calculate lambda. Now let me draw what that triangle is going to look like. The red line that I just drew is the same as this dotted red line.
All right.
Here's lambda. What's this dimension? The first line that I drew?
25.
What's the bottom side of this right triangle?
43.
Nope.
Would that be half of 43 then?
Yep. So it'd be 21 and a half. So lambda is equal to what? And just give it to me not as a number, but in terms of what?
The square root of 21.5 squared plus 25 squared.
Good. Let's leave it at that. Now, to calculate...
Once you get that answer, you plug in that formula, right?
Exactly. So lateral area is equal to 1/2. What's the perimeter?
The perimeter is 43 times 4.
So there's the perimeter, and then lambda is that. So that's our answer. And again, let's not take the time to actually do it. You can do all of the arithmetic afterwards.
Right.
I wish I'd have thought of this before. I actually think this makes a difference.
Yeah, I feel like I'm understanding it more, not trying to focus on my calculator.
Exactly. Okay, find the surface area of this figure to the nearest whole number. Well, once again, it's a little tough to figure out whether there's a bottom on this or not. I guess we are to assume that there is. As long as you know, in other words, it's an ambiguous question because it doesn't really show you whether this is a tent or that it's a box and it has a bottom to it. So we'll assume that what? That it's a box and has a bottom?
Yeah.
Okay. So surface area.
Although, if it was a box and at a bottom, wouldn't they have to draw in the other
Maybe,
side?
maybe the dotted lines. They would need some dotted lines on the bottom. Perhaps. I don't know. If that's the convention, that's the convention. For you and I, it doesn't really make any difference. Because on a test, you're going to know, I presume, whether there's a bottom on this thing or not. So you and I can just do it both ways. As long as you know how to do it, that's the key.
Okay.
Let's assume there's no bottom.
Alrighty.
Okay. So the surface area will be the lateral area of the box plus the lateral area of the pyramid.
Alrighty.
Correct? That's all we have. We don't have a base of the pyramid anymore, and we don't have a top to this box.
Right.
So the total surface area should be just this. And what's the lateral area of the box? Boxes are pretty easy.
The lateral area is just, isn't it 4.5 times 4.5, or no, times 6.
Start with the front.
Alright, 4.5 times 6 times 2.
Correct. That covers this front base and the back.
Alright, and then you do it again for the other side, except would you times it by 2 there since we can't see?
Yep, because there's that. We know there's a back side to this thing, even though they haven't drawn the dotted lines. In other words, there's an opposite face to this.
Okay.
So it's another 4.4. We could just say times 4.
Alright.
In other words, this is a square pyramid. And the lateral area of the pyramid again?
Of the pyramid is half perimeter times lambda.
And that's another thing that I think it's worth doing, is always start with the general formula. Don't shortcut. Because if you start with the general formula, every time you do a problem, you'll never forget it. If you start plugging in, you look in your book and you see what the general formula is, and you just plug in numbers, it's not going to be nearly as reinforcing in your brain.
Right.
So, what's the perimeter?
The perimeter would be 4.5 times 4.
And lambda?
Lambda is 3.
Right, they give it to us here. So that's our answer. Would be this plus this, unless there's a bottom, and if there's a bottom, then it's also 4.5 times 4.5 for the area of this bottom. Okay?
Alrighty.
Okay, the surface area of the cone in terms of pi. So the surface area of a cone, what's the general formula?
Pi r squared plus 6. pi r lambda.
Okay. Pi r squared for the area of the base.
Right.
Plus pi r lambda. Exactly. That has a ring to it. Pi r lambda. And always remember it like that. In other words, don't sometimes write it lambda pi r. If you always write it pi r lambda, it fixes in the brain easier. So the area of the base is pi r squared plus pi r lambda, and that's pi times 3 squared plus pi times 3 times 15.
So then it's just do the arithmetic. Okay, to find the slant height on that one, you just make it a hypotenuse, right?
Yes.
All right. So 10 squared plus 19 squared, or I mean the square root of 10 squared plus 19 squared equals lambda.
Exactly. Okay. The lateral area of a cone is equal to 103 pi. The radius is equal to 37. Find the slant height to the nearest tenth. So what's the first thing I want to write in the way of a general formula?
To find the slant height?
Well, they've given us lateral area and they've given us radius. So let's start with the general formula for lateral area.
That be pi r lambda?
Now fill in the two things they've given us.
Alright, so the radius is 37, and lambda is 103.
No, lambda isn't 103. The lateral area is 103 pi.
What
They're
is
asking
the
us,
lateral area versus lambda then on a cone?
lambda is this length, a linear measurement, and the lateral area is that area.
Okay.
In other words, if you had a cone and you could cut it up apart and measure the area that you had laid out flat, that's the lateral area.
Okay.
Okay, so now we have a formula that pi's cancel, lambda is equal to 103 divided by 37.
Alright.
Okay. Surface area of a conical cone.
That's just cone, right?
Grain storage tank has a height of 30. All right, let's draw it. Storage tanks are shaped like this. But I don't know if that really helps us. Let's shape it normally. It could be shaped like this, I guess. Let's see. I have a height of 30 meters. A diameter of 20 meters. Now, which makes the radius 10. Let's just write it like that. And a slant height of 32. Why would they give us that? You would think they would at least make us calculate that. You know what I'm saying?
Yeah.
Okay.
So then pi times 10 times 32.
Well, that's the lateral area. They want the total
Oh,
surface area.
oh, right. So then just do the base of the area, which is 100 pi, and then you do pi r lambda.
Yeah, now again, I'm not sure we know that there's a base. I have that question on every one of these. When you take tests, do you have that question in your mind? Ever?
Well, occasionally, most of the time the tests are drawn out, so the
Okay.
figures aren't hard to see.
Okay.
So I
Okay.
don't get what's up with this one.
Because again, if there's no base, in other words, if this thing is just a cone on the ground, or if it's an open tank like this, where the grain
Right.
goes in here and comes out a little hole here, then we're just talking lateral area, and it would be only this. So as long as you understand the difference, in other words, that's the area of a base if there is one.
All right. The pies would cancel out there, wouldn't they?
Yes.
Okay.
Well, no. They're being added. So we would have 100 pi plus 320 pi, we would have 420 pi. There's no division on both sides by pi. On the previous problem, yes, the pi's canceled out because they gave us the lateral area and wanted us to solve for lambda.
Okay.
This problem, they give us all of the dimensions and want us to solve for the surface area again.
Alrighty.
However, in this case here, they do want you to round it to the nearest square meter. Wish they'd make up their mind. You know what I'm saying?
Yep.
Whoops, hold on a second. Get it here.
So now it's volume, so it's pi r squared times the height.
Correct.
Right?
Mm-hmm. How about this?
Are they still looking for volume there?
I'm trying to see what... Yeah, they want volume here.
It'd be the same thing then.
Yes.
Pi r squared, so...
Times the vertical height. In other words, it's very much similar to finding the area of a parallelogram. In other words, that is to a vertical right cylinder as a parallelogram is to a rectangle. Right? In a parallelogram, we take the base times the vertical height. Same thing with a slanted cylinder. We take the area of the base times the vertical height to find that volume, not the slant height, I think.
All right. How do you get the, like
Hold
if
on.
they only give you slant...
Hold on a second. I'm puzzled because I'm puzzled why they're asking you this question. This actually invokes Cavalieri's theorem, which is a calculus theorem. Let me see if this book that I have talks about Cavalieri's theorem at all. Because I'm not 1,000% sure that it's the vertical height. It could be the slant height, which would make it more sense that they would give us the problem. Let's see, my geometry book does not have Cavalieri. I know this one does. In fact, no. It's funny that they would give you this problem because this is a rather sophisticated concept. And the concept is that if you take a stack of coins that would normally be stacked in as a right cylinder,
Right.
and you slant them, it does not change the volume. So, says Cavalieri's volume theorem says that solids with equal altitudes and identical cross-sectional areas at each height have the same volume. In other words, this has the same volume as if I straightened it up and took the vertical height. Still isn't clear to me whether that's going to be the slanted one or the vertical one. Hold on, I might be able to determine. I'm looking in my calculus book to find this. It's the vertical height, almost positive. So what's the volume of that thing?
Pi r squared, so 9 pi times 6.
Okay.
So, yeah. 54 pi.
Yeah.
So I'm not sure how to do 12 at all. Like,
Okay. They're making the problems a little harder by not asking you about volume. If they ask you about volume, could you do that? Let's say that they gave us h and they give us the radius. What would the volume be? What's the general formula for volume?
For a cylinder, it's still pi r squared times the height.
Okay. So that's our general formula. But instead of giving us R and H, they've given us the volume. So what can I write next?
What do you mean?
What's the next thing I want to write to solve for H? They want us to solve for H.
Right.
Well, they've given us 2 out of the 3 things. We have an equation with 3 variables.
Okay, so you put 271.4 in for V.
Exactly. What's R?
R is 6.
Solve it for H would be dividing the left side by pi, 36 pi.
All right.
Okay, whoops, can't take away that line. And that's all you do. In other words, our equation has 3 variables: volume, radius, and height. Pi is not a variable. So they can give us any 2 of the 3, and we can calculate the other one, because we'll be able to write an equation that only has 1 variable.
Okay.
In other words, maybe they give us the volume and the height. Then we could figure out the radius.
By doing the same thing.
Yeah, it'd be a little harder to solve for radius because we're going to have to take the square root of both sides at some point, but not really any harder. The fact is that as long as they give us 2 out of the 3 variables, we'll be able to solve for the third one, no matter which one it is.
All right.
What's the formula for volume of a pyramid?
Whoa. I do not remember that one.
The fact that it goes to a point, what does that tell you? What's the formula for the volume of a cone?
The volume of a cone, 1/3 pi squared, r squared.
It's the area of the base. In other words, it's the same as the volume of a cylinder, only it's only 1/3 of it because it goes to a point instead of a full cylinder all the way up. And that's the key thing to remember, is that when you go to a point, you lose 2/3 of your volume.
Okay.
So if we remember that, well, now we're looking at a pyramid. pyramid goes to a point also. Same thing. So we're going to need something with 1/3 as opposed to a rectangular or a square brick where it went straight up.
Right.
You know what I'm saying, the difference?
Yeah.
So it's 1/3, and what's the rest of it?
1/3 would it be the base times lambda?
Area of the base. Notice that this is the area of the base. Only for a pyramid, what's the area of the base? The general formula. It's the side squared
Okay.
times height.
Alright.
In other words, it's very similar. Notice how similar these two things are. This is the area of the base times the height times 1/3. This is 1/3 times the area of the base times the height.
Alright.
Okay, so those are the two key formulas. Now let's plug in.
Alright, so we do 12 squared times 10, and then divide it all by 3.
Right. Two square pyramids shaped just like before, the problem we just looked at, have the same volume. For the first pyramid, the side length of the base is 20. For the second pyramid, and the height is 21, excuse me. So the height going right to the middle of this thing, that's 21.
Alright.
The second pyramid has a height of 84. So this line going up to the top would be 84. What's the side length of the base? And they have equal volumes. The volume of this one equals the volume of that one. And what they want is the side length right there.
Alright. I'm not sure how you would do that. Like,
well, let's figure out the volume of this. Can we figure out the volume of the one on the left?
Yeah, it's 20 squared times...
Start with the 1/3. I really prefer you start with the 1/3 rather than when you get all done dividing by 3.
Right.
Just because, again, it locks it in your memory more. If you always start with that 1/3 the moment you see a point and you're dealing with volumes, and it's important that that 1/3 not get squared. It's 1/3 times 20 squared times the height of 21.
Okay.
Okay? Well, they're saying that these two things have equal volumes. So whatever that number is the volume of this other one. So I'm going to write the volume equals 1/3 s squared times 84, correct?
Right.
And in place of v, I'm going to write this number here. 1/3 times 20 squared times 21, that's the volume of this thing, equals 1/3 times s squared times 84. Notice that there is only one missing variable, or there's only one variable there. Everything else is a number. So they're asking for the side length of the base of the second pyramid. That's what we're going to be able to solve for, is s. However, on this one, I want to go through the math.
Okay.
Make sure you can solve this. What's the first step?
Alright, so first we're going to want to get what's on the left side all in. So,
okay, before you do that, before you can multiply everything out, is there anything we can do to simplify stuff? What about this 1/3 on this side of the equation and the 1/3 on this side of the equation?
okay, I wasn't sure if you wanted just one equation. Yeah, we can get rid of both those 1/3s.
That's helpful because otherwise you have to do that 1/3 calculation twice. You got to do it once over here, again over here. Pointless. Always simplify. What else can we do? Divide both sides by
7.
how about 21?
Okay.
21's cancel, and 21 goes into 84 exactly 4 times. So now we have 20 squared equals 4s squared. Now we're going to have to multiply stuff out. What's 20 squared?
All right. 20 squared is 400.
What's next?
And then you divide everything by 4, wouldn't you?
What's next?
100 squared.
How do you solve this for s?
Well, wouldn't you want to get s by itself?
Yep. How do you get s by itself?
The square root of 100.
Okay.
So
It's not 100. It's not 100 squared. There's a big difference.
yeah.
It's the square root of both sides. So s is equal to 10. That's the first time we had one where we were going to have to solve it by taking the square root. That's why I wanted to do it.
Right.
Okay, the volume of the cone, what is it?
1/3 pi r squared times the height.
Which in this case?
Pi r 5 squared, so 25 times 14.
And notice the difference between the volume of a cone, you use the vertical height. When you're looking at the lateral surface area of a cone, you use the slant height.
Right.
Okay. It's the surface area of a sphere. What's the volume of a sphere?
I don't know this, so
Again, the volume of a sphere is a lot like a circle. The only thing that matters is the radius.
all right.
If
So
you know radius, you know everything. And how to memorize the 4/3, I don't know. Just kind of have to memorize it as 4/3. However, well, this isn't going to really help a lot, but the surface area of a sphere is 4 pi r squared. Notice that the volume gives you cubic centimeters and the surface area gives you square centimeters, which is as it should be. Surface area is the same thing as the area of a rectangle or the area of a circle. It's two-dimensional, whereas volume is three-dimensional. So the volume of the sphere is what?
the volume of the sphere, so it's going to be 7.5 for the radius.
Cubed.
And we're going to cube that.
Yeah, just leave it. For our purposes, we'll leave it like that. All right. The volume of a sphere is this much. What's the surface area of the sphere, the same sphere?
So you'd have to cube root the volume.
Basically, yeah. Let's go ahead and do it. Let's do the problem.
Cube root 3,000.
Well, don't think cube rooting yet. Let's start with the formula and plug in what we know.
Okay, so we don't know anything yet
We know the volume of the sphere. It's 3,000 pi.
Right.
So I can say 3,000 pi.
Oh, equals 4 pi.
No, I'm talking volume. 4/3 pi r cubed. We don't know the radius.
The surface area, doesn't it?
Well, it does, but in order to get the surface area, we need the radius. And in order to get the radius, we need to solve this equation.
Okay.
So it's a two-step problem. That's why they gave us the volume, because that means we can figure out the radius. And once we have the radius, we can figure out the surface area with the second formula.
All right.
Okay, so what's the radius?
So,
Let's solve this equation. What's the first step?
we can get rid of the pi's on each side.
Okay, second step?
Can we divide 4 over 3?
Okay,
No.
I prefer to think of it as multiply both sides by 3 and divide both sides by 4. So we end up with 9,000 when we multiply by 3 divided by 4 equals r cubed. So r is what?
We don't know the radius yet.
Well, we can solve for it. We got this much information. I can solve for r. It's one equation and one variable. How do I solve for r?
Do 9,000 divided by 4 and get 2,250.
Okay, that's r cubed.
Right, and then we cube root that.
Okay, so it's this number to the 1/3 is what r is. Okay, we'll just leave it like that for a moment.
Right.
Now, surface area of a sphere is 4 pi r squared. And this is not that hard to memorize. If you can remember the volume, which is 4/3 pi r cubed, well, surface area is like pi r squared only times 4. And there's a 4 right there. So know that there's a 4 in both the volume and the surface area of a sphere. So they want us to solve for surface area, so I'm just going to plug in everything we know. 4 pi, r is 2250 to the 1/3, and they want me to square it, which makes it to the 2/3. If I square this number right here by taking both sides to the 2, now I multiply the 2 times the 1/3, and I get that number to the 2/3 using the rules of exponents.
All right.
Okay, so there's your answer. This was a good question because we needed to solve for radius by knowing the volume formula, and then we needed to solve for the surface area by knowing the radius that we solved for in that.
All right. So just to make sure, since we're, that'll come to, just to make sure I'm doing it right, that'd come to 171.7, wouldn't it?
Don't know. I don't have my calculator. Are you doing 2250 raised to the 2 over 3 in parentheses?
Well, I cubed root it already before you said that.
Okay, and then squared the result?
Yeah.
Okay, that'll do it.
Okay. Alrighty then.
What answer did you get though?
171.707.
Just for this part? Just for 2250 to the 2/3?
Yeah.
I got a calculator here. It's my smartphone. My other calculator broke. 2250 raised to the 0.66 power. Right? That's another way I can do it.
Right.
I get 163. Is that what you got?
I got 171.
Wow, could it make that much difference that I rounded off? 2250 raised to the 2 divided by 3. Let me try it that way. No. Oh yeah, no, that works. I get 171. Wow, look at the difference between using 0.66 and using 0.66666. That's 8 difference. 171 is precise. My 163 was the rounded off number. That's really amazing. It makes that big a difference. All right.
Just wanted to make sure I had that one right.
Yeah. Now you still have to multiply that by the 4 pi, but
Right.
okay. 19. Find the similarity ratio of a prism with surface area 36 square feet to a similar prism with surface area of 225 square feet.
Wouldn't you just do 36 to 225?
Well, it's important that we know what similar square pyramids mean. And that they have to be exactly the same shape. In other words, I can't have a square pyramid over here that's taller with the same base.
Right.
Okay, so when they tell me that they're similar, I can make the base different, which I am here, but the height is going to be whatever the relationship is of the base, that relationship has to hold between the height.
Right.
Vertical height. Okay, so all of these problems, the similarity ratio is going to be the measurement, the ratio between x and y, right?
Right.
Okay, so what we're looking for is y over x, the bigger one over the smaller one. Okay, it tells me that the first prism has a surface area of 36 square feet. What's the formula for surface area?
Formula for surface area of a pyramid. The base, like x squared
Area of the base.
plus half the perimeter of lambda.
Okay. So in this case, it's x squared plus 1/2 the perimeter, which is 4x, right?
Right.
Times lambda, which we don't know. The surface area of the bigger, and that surface area, which they're giving us, is 36.
Right.
This is a toughie. Okay, the surface area of the bigger one is also equal to the area of the base plus 1/2 p times L. And they're giving this surface area is 225. So area of the base is y squared plus 1/2 times 4y times lambda of the bigger, because it's not the same lambda. Okay?
All right.
Well, what do we have here? We have 2 equations and 3 unknowns, because we have x, we have lambda, the smaller lambda, we have y, and we have the larger lambda. Well, we cannot solve 2 equations with 3 unknowns. But we know a little bit more, is all we're really trying to solve for is y divided by x.
Right.
And we know that big L divided by little l is the same thing.
Right.
As y divided by x.
All right.
I'm thinking here for a moment. We know that y divided by x is the same as big L divided by little l. So if we can solve big L divided by little l as a number, we'll be home free. Thinking. All right, let's just proceed with what we know. Little l is equal to 36 minus x squared. This all is 2x divided by 2x. Right?
Yeah.
Okay. And over here, big L is equal to 225 minus y squared, all divided by 2y.
Right.
So we're looking for big L divided by little l. That will be the similarity ratio.
All right.
So if I
But
take
you
big
get,
L,
2y and 2x from, like, in the equation you have half times, in parentheses, 4x.
yeah, so I just reduced that to 2x. In other words,
Right,
that
okay.
becomes 2x.
Okay.
This becomes 2y. So when I divided by my coefficient, it was 2y over here, it was 2x over here.
All right.
All right, now if I'm looking for big lambda over little lambda, I divide that whole thing by little lambda. Which is big lambda divided by little lambda. And that's our similarity ratio. Now, the problem is we need a number. This is a toughie. I'm not sure I know how to do this. Conceptually, I can see that you should be able to do it, but I'm not, the math isn't, the algebra isn't working out for me. And we've kind of run out of time, so we're probably going to have to stop here.
All right. I can go in and talk to my teacher about it.
So this one just went through 20. Yeah, I
Yeah,
have
and
to
then
think about this one for a bit. There's probably something I'm missing here. It doesn't really look like 20 is easier. I think you'll be able to handle 20. 19 takes a little doing. I'm going to have to think about 19.
all right.
We can
Well,
maybe...
I had one more quick question for you. So when we first started, you said there was a way you could send me the recorded sessions, like if I wanted to preview the one we just did.
Yep.
How can I get those?
I will send you a link right now. Okay, ID 68. Hold on. This is your page.
All right.
It will have the most recent one right there, and the one before that, it'll be this one. And I'm going to copy and paste this into the... There's the link right there. Copy that and save it.
Awesome.
And then you'll always have it as a favorite. This Algebra to Calc ID 68. That's your page. The most recent session will always be at the top. Now it will take a few it'll take a few hours to process this. So it's always 4 or 5 hours after the session.
Alrighty, I just wanted to review all of it and make sure.
You've got every session. Look how many sessions are on here. They're all in YouTube format. So you can review them anytime you want, right on the site. You don't have to download anything. It'll play.
Awesome.
Okay?
Well, very good. Thank you.
All right. See you next Wednesday, Ryan.
Alrighty.
Bye-bye.